You see before you a whole bunch of index laws. Now, this video is not about index laws, it's about the equivalent laws that you will find for logarithms. I'm not going to go through every single rule for logarithms. In class, you'll have a booklet which will go through a whole bunch of different log laws or log rules. But we're going to have a look at a couple in this video, because if I show you a couple, I think you'll get a feel for how you do the rest of them, really, which you can do in class. So here are the index laws. A to the power of m plus n equals a to the power of m times a to the power of n. A to the power of m minus n is equal to a to the power of m divided by a to the power of n. A to the power of m raised to the power of n is equal to a to the power of mn. A to the power of m over n is equal to the nth root of a to the power of m. A to the power of negative n is equal to 1 on a to the power of n, and the vice versa is true. I didn't put that down, but 1 on a to the power of negative n is equal to a to the power of n. And there, this is the one rule which has the different bases, but if you've got two different bases raised to the same power, so a to the n times b to the n, it's equal to ab to the power of n. And there's one other rule I haven't written down. It's probably one of the fundamental ones, and that is that a to the power of 0 is equal to 1. And we've seen how these index laws are generated based upon basic understanding of what an index is, a repeated multiplication. When you see the log laws, you'll see that they kind of, there's a reason why the log laws kind of look similar. Alright, so let's have a look at just a couple of outcomes of these index laws and how they apply to index laws. So first of all, let's have a look at this. A to the power of 0 equals 1. Now, let's just remember that the logarithm is defined as the log base A of C is equal to B, means, I'll explain that symbol in a second, it's an equals with an arrow either side, that a to the power of b is equal to c. That's the log definition. You need to be familiar with that log definition. Now I'll just explain what this symbol here means. It means it goes both ways. It's not an equal sign really, it's just an arrow with a double-headed arrow. And it means that if this is true, then that is true. And if that is true, then this is true. So if log base a c is equal to b, then a to the power of b equals c. And it also means if a to the power of b equals c, then log base a c is equal to b. So it goes both ways. If it only had one arrow, it means it would go one way, but not necessarily the other. So anyway, that's just a little bit of terminology, but this is what we're looking for here, that both of these things are true. So that means that if we do have a to the power of b equaling something, then we can rearrange it. So what does it mean in terms of this thing here? Well, we've got a log base a, we've got a power 0, and we've got a result as being 1. So let's rearrange that using this definition and see what we come up with. Log base a, so the a stays the same, of the result 1 is equal to the power 0. So log base a1 is equal to 0. There's probably a whole bunch of different kinds of little results you can get out of that. Like, for example, if I raise any number to the power of 1, I get that same number back. So 10 to the power of 1 is 10. Negative 2 to the power of 1 is negative 2, a third to the power of 1 is a third, and so on. So that a to the power of 1 equals a. Now if I use my my logarithm definition, then given that, I'll just underline it, or put a square box around it, that's the base, that's the result, then we can see that the log of the base, sorry, I'll just match the colours up there. The log of the base of the solution equal to 1. Okay, so in other words, say log base 17 of 17 is equal to 1. Okay, that's just something that naturally occurs as a result. So what have we got? We've got log base A1 is always equal to 0, whatever A is. Log base AA equals 1, whatever A is. And there's probably a few other things that you can solve as well, but that's just one little outcome. It's not really a law, it's just something that if you think about it, it kind of makes sense. Let's have a look at one of the first basic laws of logarithms. So here's one of the first basic rules of logarithms, and that is if I have a log to a base of x and I add log to the same base of a different value, or the same, can be the same, of y, it's equal to log that base of x times y, not x plus y, but x times y. Now this is quite a handy little rule to know. So if I'm adding two bases together, two logarithms together, sorry, with the same base, then I can simplify that into one logarithm by multiplying those numbers together. So for example, if I have the log of base 2 of 4 and I add the log of base 2 of 2, then I can say that's log base 2 of 4 times 2, which is log base 2, 8. And remembering our definition of logs, which is log base AC equals B, then A to the power of B equals C, then 2 to the power of what equals 8? 3. So that's equal to 3. So that's just a very simple example of how we might have been able to use the addition law there. So how does it come about? Well, I'll show you on the next page. So you won't have to do this so formally when you're discovering the log rules in class, by the way. I'm just doing this so you can see how it's done, and you can do the same sort of theoretical solution writing yourself if you want to. Let x equal a to the power of m. Okay, in log form that would be log base a x is equal to m. And let's let y equal a to the power of n. So in log form that's log base a y is equal to n. Let's consider xy. So multiplying x and y together. What does xy equal? Well, just by substituting in from how we defined it, it's equal to a to the power of m times a to the power of n, which equals a to the power of m plus n. I'll even put it in, you don't have to normally put it in brackets, but I'm going to put it in brackets so you can see where I'm going here. So we have xy equal to xy equals a to the power of m plus n, and again from this point we're going to apply log base AC is equal to b if and only if a to the power of b equals c. So we're going to apply this little logic again to this point in our solution. So if xy equals a to the power of m plus n, then log base a of xy is equal to m plus n by definition. Okay? By definition. But what does m and n equal? Well, up here we have m equaling log base a x, and we have n equaling log base a y. So all we have to do is substitute log base a x for m and log base a y for n, and our proof will be finished. So we've got, which equals log base a x plus log base a y. Done. We've proven what we set out to do, which was that when we have two logarithms with the same base added together, then we just have to multiply the values inside the logarithm that we're that we've got. So there you go. So I'm going to leave the video there so it's not too long this time, and we'll use this video, or use this kind of logic, I suppose, to discover the rest of the logarithm rules. And you might even be able to, right now, have a look at the other index laws that I showed you at the start of the video, and maybe see for yourself some of the common logarithm laws and how they might relate to the index laws. But I'll leave that up for you. But we'll look at it in class. That's it from today.